Well, here it is, the $50 special delivered to your door, MS310. Calling it a 310 right here, 59cc, and it's calling it a 310 right there also. Missing a few parts here, got some spiders living in here. I think the choke rod might be okay, handle might be okay, fuel lines will need to be replaced. A little bit ugly on this side, everything's froze up, nothing's turning, and we can see this thing was in a fire. All this is burnt up. A little bit of the housing got burnt here. Same with up here. The buffer's burnt in here. The handle's burnt out. But most of the case looks pretty good. Take the sprocket cover off. Take the dogs off. Take the chain tensioner off. It's kind of stuck in there. Take the little stop plate out. Pry the chain guard off. Top and bottom. Pop the clutch cover off. Well, this is really pretty looking, isn't it? Well, everything's completely seized up in here. Chain tensioner's all seized up, chain brakes all seized up, clutch is all seized up. As we get the components to come off, we're going to take them to the wire wheel, see if we can shine them back up. I got a feeling we'll be able to use most of this stuff. I'm going to pry out the buffer covers. Just going to try to pry on this part. I don't know what's going to happen here. Got it. Pull the 3 screws from behind the buffer covers. We got to get back in here and pry the brake spring off. I'm going to put a rag over it. Take the brake spring out. Looks okay. We're going to knock this clip off. And don't lose it. We can reuse that. Try to pry this little plate off. I bet that'll clean up. I'm going to try to wiggle our brake handle off. Everything's seized up in here, so nothing's going to come out for us. Let's try and pry the brake band off. Oh, it's coming. We got lucky. The brake band is usually stainless, so you're usually in good shape here. It's all melted in down here at the bottom though. There, it came out. We'll be able to reuse that. Try and pry these linkages on out of here. Pretty froze in here. Nothing's moving. We got a washer that wants to come off. Rusty, but we can save it. I think I'm prying the whole stud out, but it's coming. Hey, we got it. Yeah, the whole stud came out. That stud's supposed to stay in the housing here. We got a buffer up top here. The release pawl needs to come out. It sits on the peg with a clip. Pry the clip off. Success. It's rusted in there pretty good. The muffler's in the way to pry this top buffer out. We got to remove the muffler first. 3 nuts and 3 washers came off. I can't believe it. And slide the muffler out. Pretty heavy. I think it's full of crap. Lube up the impulse line and work it back through. Gonna have to push the intake through. Remove the little support rings. Try not to damage your intake. Finger it right on through there. Pop the kill wires off. You gotta support the throttle and pry this bottom one out. Free up the wires. They're gonna pull right through. Coming. Held up on the wires down here. There they go. And we got the handle off. There it is. Upper housing and handle. Pretty nice and burnt up in there. But it's surprisingly still in usable shape. It's burnt, but it's not busted. Pop the spark plug boot off. 2 screws hold this upper shroud on. Shroud looks alright. This is still usable. Take the ignition module off. Work the wires out. Take the intake off. Probably going to be stuck on there pretty good. Dirty and ugly, but it doesn't look bad. Looks like it's still a good intake. No damage to it. The clutch is standard thread, 13mm. If we're lucky, it'll be locked up enough we won't need a piston stop. We'll just be able to take it right off. We got it. I felt the piston starting to move, but one good whack knocked it right off. This thing's seized on here pretty good. There's no puller holes to use a flywheel puller. We're going to give it a little heat and try to pry it off. Pretty dang stubborn, but it came off. We'll get this flywheel nice and cleaned up. But it looks okay, it looks undamaged. Because of the plastic housing, the coil has to ground to the engine block. The clutch has to come off to remove the motor from the cradle. We'll undo the little clip. Clip looks okay. Washer's coming off, but I'm not sure that's the right washer. And this guy's locked on pretty dang good. This won't be easy. Keep prying and prying and prying. And it finally freed up. I can see a whole bunch of needles in here, so we're going to need a new bearing. And there's a little bit of crud in there. But look at that beautiful clutch. Well, I gave it a good whack and something's happening. I'm not sure what's happening, but something's turning. It's very difficult. It was hard to break free. Well, we got it off. Look at that beautiful thing. I think we're going to need some springs. The washer behind is free. I can see the worm gear. It's completely melted in. This might be the source of our fire. Looks like this area heated up and caught this lower area on fire. Get you in here so you can see what it looks like. See that worm gear? Everything in there is melted to heck. There's supposed to be an oil pump in there somewhere. Well, we got to start prying out the melted crap and see what we can get out of here. Wow, big old chunk. Oh, the worm gear's moving. It's coming out. Ta-da! Look at that worm gear. It's like brand new. But behind the worm gear, down on in there, doesn't look too bad. I can see the drive gear, the oil pump is rotted out, but the shaft looks okay. There's some slight bluing out here where it overheated. See if we can get this oil pump out next. Hey, it's coming out. One hose came off, and the other hose came off. Look at that oil pump. Wow. Now we can finally get to the 4 screws holding the motor on. This one had some melted housing over it. These are on really tight. We'll wiggle this guy on out of here. Hey, look at that! The bottom half of the clamshell came off. Here's our crank. Real pretty, huh? We're gonna have to get creative and clean this thing out real good. We're gonna try and tap the whole crank and piston out. Got it. Finally. Holy moly. That poor thing was in there. Well, nothing will rotate at all. Everything's locked up. There is nothing that will freewheel on here. Not the prettiest of contraptions, but we might be able to salvage it. Doesn't look too bad down in that cylinder. We might be able to use it. Well, I rinsed off the cylinder, so let's throw it right in the ultrasonic cleaner and see what happens. The back bar stud bolts into the clamshell down here. I got the 2 nuts on it. We're going to try to spin it in reverse now. And it's tight as heck. Oh man. Wasn't easy, but we got it. There it is. Get the clam out now. Get this all cleaned up. We probably could reuse this case. I wouldn't recommend it. The little oil pickup line is barely usable if you wanted to, but I think we ought to replace it. The other oil line down here is probably not usable. That's an easy replacement. But I found this aftermarket case. Should be a direct replacement, so let's give it a try. Well, I think I got everything off. We got the oil line out, the fuel line out, and the pulse line out. The oil line I just so happen to have. Here's a match for the oil line. The other box just so happens to have the fuel line we need. There it is, there's our fuel line. And the pulse line is this clever design. It makes installation real easy. But we can go generic and just use heavy duty fuel line. It's the same stuff. But I also found the pulse tube in the box, so we'll go ahead and use the pulse tube. Well, I was hoping to rebuild the oil pump, but there's a crack in it right between my thumbs. There's a crack that runs right through here. So instead of rebuilding, we'll just look for the oil pump box, and wouldn't you know it if we don't have a match. Now the aftermarket isn't any better. The gear is locked up on the original one, it won't turn at all, and the gear is locked up on the aftermarket one. This gear won't turn at all. The cutting fluid they use to mill these out with hardens, turns into this thick brown paste, and hardens in there like epoxy. You have to take these apart in order to get these aftermarket pumps to work. If you don't, it won't work. Let's take a look at the OEM oil pump. We got to start by driving out this pin right here, and then work out the adjuster screw. We got this big brass looking plug in here we got to pry out. I had to get in here with a razor blade and use a razor blade to separate it, and then use a screwdriver to pry it out. You can see it's both a plug and a support for the shaft in there. It supports the worm drive shaft. Now you can pry the worm gear out that opening. This one's all seized up, but it's coming. There it goes. Pull the worm gear shaft out, dump the spring out. Boy, you can see down in there, it's not very pretty. A little bit on the crummy side, but let's see what we can do. The aftermarket oil pump comes apart the same way. Pound out the drift pin. They give you a rubber stopper instead of a brass one. Pry out the adjusting screw. Wow, that's really jammed in there. Well, the adjusting screw was completely jammed in there. It was completely locked up. There's no way this pump would have ever worked out of the box like this. The gear is so froze up you would have burned up your worm gear as soon as you put it in your saw. You would have been back to this in no time. Boy, you could see how crummy that was. There's no way that would have ever pumped any oil. It would have burned up your worm immediately. It was 100% seized in there. Try and pry out the gear. It's coming. Better than the adjusting screw. And there we have that. Well, we got them both cleaned up, so let's do a comparison. OEM oil pump on the left. You can see the shaft difference. The OEM has this extra section of shaft out here, whereas the aftermarket does not. The OEM also uses this bearing bronze stopper to support the end of the drive shaft. The aftermarket does not, it just uses this rubber stopper. The OEM uses 2 washers and a spring. The aftermarket only uses 1 washer and a spring. The OEM uses a double O-ring on the adjuster peg. The aftermarket just uses a solid chunk of steel on the adjuster peg. Both utilize the same drift pin to hold everything in place, and the OEM has 1 extra knockout at the end. The aftermarket does not. Same worm drive. They do accept the same worm drive, same mounting, same oil in and out. So very subtle differences, but on a very close inspection you can see the machining is less superior on the aftermarket. The OEM machining and components are indeed superior quality. This aftermarket pump will run now that we cleaned it up, but I'm probably going to use the original pump. Even though it has a crack in here and it's a little bit worn out from the heat, it's probably going to work better than the aftermarket. But this aftermarket will work now that we cleaned it up. If you run these aftermarket parts, you really got to do a thorough inspection on them. Usually you got to end up repairing them, which would probably put you back to an OEM pump just to begin with. Well, we'll start with the shaft. We got spring, washer, spring. Put a little grease on here. Insert the whole thing into the pump body. Check the spring action is working good. That looks really good, real smooth. Push it in against the spring and then insert the bottom adjusting peg screw. We'll confirm that it still rotates in here. We'll put the in plug cap on here and we'll squeeze the pin through with a pair of pliers. That feels really smooth. That gear rotates nice and free. That'll work really well. That's an impressive fix right there. It's in really good shape now. Well, the muffler's a little rusty, so let's rig it up for an electrolysis bath. Give that a try. Well, we got our 2 pieces, the muffler and a piece of scrap iron. Well, we're running about 13.5 volts and 4 amps. Well, here it is, fresh out of the drink, and it's better, that's for sure. Well, we got the chain tensioner and the brake linkage all prepared for an electrolysis bath. The chain tensioner is locked up, it won't spin at all, and the chain brake links are locked up, they won't move either. So let's see if electrolysis will solve this. Well, the brake link came out pretty good. It's now free, pin pulls right out, so that's a win. The chain tensioner is now free. So we did pretty good there. We got to back this all the way off, disassemble it, and shine each of the parts up now. Well, we got the money components in here, the piston and the crank. And for an anode, I'm just using a big wad of wire. It's easy, clean, and fast. So just use about 3 extra feet of wire. A lot of stuff coming off the crank down there. It's really coming off. Well, that's only 5 minutes and you can see how much crap it's pulled off. It's really taking it off. I had to clean all the crap off the wire because I was getting poor current flow. You can see the results. It's really removing some stuff now. When you examine your aftermarket case, you'll find no shortage of problems. Down here in the bottom where the oil pickup line goes, you can see a big chunk of plastic stuck in there. That has to come out or you'll leak oil right there. I can see the screw hole in there is almost obstructed. This one has an issue with the plastic molding. You can see the screw won't sit very flat when it goes in there. And not to mention the screw won't even go down through the hole. We're going to have to file out the steel sleeve a little bit to even get the screw to go in. When you put the lower clamshell on, you can see another issue. That bottom clam is rocking real bad. The 4 seats are not level. We're going to have to find out which one's sitting high and either press it down or file it down so the bottom clam sits nice and flat. If you don't get rid of this wobble, when you torque the 4 bolts down, it has the potential to pull and distort this shape. and that'll likely cause an air leak around the seals. So you have to make sure it sits flat in the bottom of the case. Well, I had to file down this front mount up here. The clam now sits level. It sits in here nice and firm without rocking. So we solved the rocking issue. The other issue was this stud wanted to align with the clam. The clam sat too high, so by filing down that mount, it lowered its seat and now the stud aligns. So it solved the stud alignment problem also. Well, the good and the bad of the electrolysis is it exposes everything. After all the rust and scale comes off, you can see how the finish has been pitted. I hate to say it, but we're probably going to have better results with an aftermarket crank. Same with the piston, it was quite pitted as well. The electrolysis amplified that. Only one ring would free up, the other ring still stuck in here. So we're going to go with the aftermarket piston here. I got the two pistons joined together by the wrist pin, and I can see they are identical. But let's take a look at the rings. Well, here's a ring comparison. The Steel brand ring has a brand logo on it, $12 a piece. The Carb brand ring doesn't have a logo, but apparently it's just new old stock, $4 a piece. And the cheap HY brand ring, between 75 cents and $1 a piece. All are 47mm rings, and all measured 1.5 millimeter thickness on the money. They're all exactly on 1.5. The cheap HY only came in at 1.9 millimeters width. The Carb came in at exactly 2 millimeters width. So that's 47 by 1.5 millimeter thickness by 2 millimeters width. They don't give you the width, but it's 2 millimeters in width. The cheapest brand was only 1.9 millimeters in width. Carb was exactly 2, and the Steel ring came out to 1.8. That's due to the wear. We've lost 0.2 millimeters due to wear. I don't have a brand new one to measure off of, but I promise you it would measure at 2 millimeters, just like the Carb ring. So we have indeed worn out the ring, and new rings will indeed help. The cylinder checks out though. It still has a real nice crosshatch pattern. It's not burned out at all. We're going to try and reuse the cylinder. Well, here we are inside the cylinder. The bottom ring gap measured at 0.2 millimeters. That's within spec. That's the Carb ring. The top ring is the used OEM ring. That gap measured just over 0.4 millimeters. 0.4 millimeters is the limit according to the book. So the OEM ring is worn just outside of spec. I can both feel and see that there's pitting on the outside of this ring. If you need help determining if there's pitting, take the straight edge to the ring, hold it to the light, and rotate it around. Any illumination showing through means the ring has pitting and needs to be replaced. Well, don't confuse burning out a cylinder with actually catching a saw on fire. When most people say they smoked a saw, they're referring to the cylinder, that they cause cylinder damage and the cylinder is no longer any good. They're not referring to actually catching the saw on fire and smoking the saw. Two different things here. Just because this saw caught on fire has nothing to do with this cylinder being bad. The cylinder wasn't smoked. The saw was smoked. And usually you don't see this. Usually you don't see the fire damage in a smoked saw. You see cylinder damage. So this is the exact opposite of most situations. Usually it's the cylinder that's smoked, not the actual saw physically on fire and smoked. There was actually nothing wrong with this whole engine. It was completely fine. The issue was it sat around too long. After this damage happened, it sat for too long before I got a hold of it. If I would have got a hold of this sooner, this entire crank, piston, and cylinder would have been completely usable. There was nothing wrong here. The issue is the corrosion from it sitting. The fire probably got put out with the garden hose or it got thrown in the swimming pool. It filled up with water and environment over the years, and that's what caused the corrosion and everything to lock up and rust out. The pitting is too far gone to salvage any of this stuff, except the cylinder. So the enemy here was the time it sat causing the corrosion. If I could have got to it sooner, this entire engine would have been salvageable, and all you would have needed to do is replace the case. A lot of people are going to tell you you can't put your aftermarket piston and rings inside an OEM cylinder. The relationship between the rings and the cylinder is off. The way the rings marry to the cylinder walls is going to be inappropriate. And that's good, true classic advice, folks. And it reminds me of another relationship called marriage. For many years, marriage used to be a man and a woman. And that got America by for many, many years. But in today's world, you can have a man and another man. You could have a woman and another woman. And this seems to be working out fine for everybody. We even have a new one in between that doesn't quite fit either, but it seems to be doing okay. A couple of them are so popular they even got their own TV shows. I don't have my own TV show. We even got Marriage Today with a whole bunch of them women and one single strange one that dominates the whole harem. And that seems to be working out just fine. So I'm willing to bet the marriage between this piston and cylinder is going to work out just fine. If you don't approve of this marriage, then you probably don't approve of these marriages too. And I don't care which marriage you approve of or don't approve of, but this marriage is happening, and this marriage is going to last, folks. Well, we got a cold crank and warm bearings, but not warm enough. Going to need to use the homemade crank puller to push the bearing all the way on. Crank this down till the bearing seats. We'll make sure we got the ring right side up. We'll insert one side into the groove and then wrap it around the piston and let it fall into the groove. Ensure it's right side up and that the ring tabs are present and flush. Well, everything's been wiped down and parts cleaned real nice. We got the caber rings on. We got one circlip in. We're going to connect the piston to the crank via the wrist pin and needle bearing. Pre-lube up the bearing, insert the bearing into the rod, lower on the piston, push the wrist pin through. When it's lined up perfect, it'll go right through. You want to make sure your exhaust arrow is pointing away and your PTO clutch side is on the right side. Exhaust goes away from the saw, clutch is on the right side of the saw. There is a tool that installs these circlips, but a needle nose works just fine if you're careful. The detent is where you'll release the needle nose. You can bring one side in and rotate it around, and then snap it in with a little flathead and confirm it sits right in the channel. Rotate the circlip gap away from the opening and we're in real nice. But do know you can cause damage with the needle nose. You can mar the circlip, so be careful. You can mar the piston, so be careful. But if you do it right, there's nothing wrong with the needle nose method. I got the shaft oiled up and the inside of the seal oiled up. I got a sleeve over the shaft for easy installation. We're going to slide the seal on. There's about a 1 millimeter ridge between the bearing and the seal. The seal doesn't ride completely against the bearing. We're going to do a test fit to make sure the seal space is correct. We're going to use a sleeve and push on the bottom of the seal only, not the top of the seal, but the bottom, to make sure we're pressed in against our ridge. Then we'll carefully remove it and set it aside. Well, the assembly is a little bit debated sometimes, but what's not debated is starting with an extremely clean, solvent sprayed, and sanitary wiped mating surfaces between the clam and the cylinder. Well, I'm pretty fast. It's only been 2 minutes. I nailed out the delicate finger method. I get just the right amount on both sides, even the section that contains the seals, because there was RTV in there when I took them off. The clamshell design doesn't exactly promote the use of a ring compressor, but the tapered shape of the cylinder allows the rings to compress as they go in. I get it in halfway, then I do a real sanitary job on both cylinder halves, not the bearing journals, but the sealing surfaces. This needs to be done wet. We're going to put both halves together while they're still wet. We're going to drop it in the case while it's still wet. And we're going to get the screws started from underneath, but not completely torque the spec yet. We're going to get them close so the gap closes, let the RTV cure, and then torque the spec. This gave me a real nice even bond all the way around the cylinder and the seal. Some people will tell you the seal should be done last, but this method does a pretty dang good job. You can always use a sleeve or a press and confirm that your seal is down all the way. A little RTV will squeeze into the inside, but RTV is harmless compared to aluminum shavings and pieces of bearing. We got some thread locker on the bar stud. Thanks to the filing we did earlier to make the cylinder sit right, that makes the bar stud thread in nice. It'll bottom out in the housing. Well, we got the flywheel surfaces cleaned out real nice. We got the keyway lined up and the flywheel mounts on real nice. Typical aftermarket, we got some interference with the case. The flywheel rubs real bad right here. We'll force it through to scar it. We'll pull the flywheel off and we'll grind this down a little bit. We can't grind too much because this gap here is important for airflow. If this gets widened out too much, we can reduce our airflow and cooling effect. We need to just remove the minimum for the flywheel to clear nice. There's the scoring right there. There's almost a flat spot. It didn't get milled in the circular fashion. We got to sand all this down. We'll do the oil pump next. We'll take our little pickup tube, point it forward, snap it into the oil pump, rotate it horizontal, put a drop of oil on the other end. There's an O-ring that it sits on, and we'll work the pump through, push it onto the O-ring. The oil pump mounts straight to the cylinder. It's the little nipple with the O-ring on it that we're trying to hit. Once you line it up, shove it down on there and confirm the oil pump is sitting nice on the cylinder. This looks pretty good. And the two 4mm screws hold it on. Got a little grease on our new oil line, and we'll install it in through the bottom. It's got that built-in little grommet that has to snap into the tank. It should seat in there real nice and flush with the housing. Use a flashlight and look inside the oil tank and confirm that it did indeed seat. That looks pretty good there. We'll put a dab of oil on the oil pump inlet. We'll push the oil hose up through the bottom of the housing, and we'll use the needle nose and attach it to the pump without damaging the hose. Get it worked all the way up on there like that. The O-ring that fit on the nipple here for the oil pickup came out of this kit was the number 2, 5/30 seconds by 9/30 seconds. The intake boot has a little rubber ridge inside here, and the cylinder has a groove around it. I lightly apply some grease to the inside, which allows the boot to sit on and relax inside that groove. The grease is an important step, or it's common for the rubber boot ring to not sit inside the cylinder groove. Massage the intake in a little bit, and then tighten your clamp. The new pulse line goes on right below the intake. Lube up the fuel line right here, and it'll shove straight down into the tank. Then fish out your fuel line and install your fuel filter. Confirm that your fuel line sits square against the indicator, and then look inside the fuel tank with a flashlight. Make sure the fuel line is seated correctly from the inside also. Now is a good time to do a pressure and vacuum test. We're going to use my homemade carburetor mount. It accepts a carburetor. We'll install it on the intake. Align the dimples with the studs. We'll slide on this test adapter. It has a plug at the bottom for the pulse line. Tighten the nuts. Install the spark plug. Hook up the tube. You can use this style block-off plate for the exhaust, but it's difficult. You gotta use the bolt support with it, and you gotta use some exhaust bolts or square head bolts. Either find some shorter ones for testing, or find some spacers to stack on here. Old wrist pins seem to work pretty good. I'm gonna use this block-off plate and then clamp it on with the clamps. And we'll pump this thing up to about 5 psi. You'll know in about 5 seconds if the pressure is dropping. You don't have to stand here and watch this thing for a full minute. If you look at it for 5 seconds and it doesn't drop much, you're good to go. I did have one leak on the exhaust side. I had to adjust the clamps, and it solved that one. And I had a few bubbles up here at the spark plug. That's why you're supposed to use a new spark plug. We'll bring it to the negative side and draw a vacuum. And same thing, it holds vacuum nicely. It's always good to work the flywheel and rotate the crank a few times when you're doing this. You'll see the needle move as it encounters compression, but then it'll recover. We held vacuum the whole time. Do that same crank rotation test under pressure too. The coil has to go on before the flywheel because the coil grounds to the cylinder here. You can't ground to the plastic case, so it grounds to the cylinder, which is hidden by the flywheel. Always use washers when you're screwing into these terminals or screwing into the coil. The flywheel should be clean and degreased. The nut and tighten. Got the filler gauge in here. Over the magnets, we're going to rotate it down over the contacts now. We'll make sure the coil's butted up against the flywheel and torque down the screws. Hold it while you torque it. You can twist the coil away from the flywheel when you torque the screws down. Back out the filler gauge and confirm there's no interference with the flywheel. The grommet kit had a grommet that would fit in right here and hold all the wires in the case. Well, when you get everything in right, this yellow kill wire behind the flywheel should be behind this grommet. The grommet holds all the wires together and then push the grommet into that groove, which will push the kill wire all the way to the back, keeping it out of the way of the flywheel. The chain brake and linkages can go on any time. We'll start by hooking the little spring up here. We'll put it so the bottom hook faces out. We'll drop in this little lever. We'll hold the spring up and we'll lock the lever into the spring. We'll verify it springs. This little linkage goes on next. The long hook hooks the end of the brake band. The other end gets the spring. It's got to go into the brake handle first. These two holes have to line up right here. So enter it in through the handle, line up the holes. Now we got to hit this stud hole and this stud hole at the same time. and you have to pry down on the little lever to get it to seat in below the lever. We'll hook the lever with a screwdriver, pry it down, and snap it in. Make sure you got the right side of your snap clip facing out, and we'll install it on this lower stud here. There we go. Confirm it's in there nice. It should rotate without coming out. We'll put this little spacer here over the other stud. Its purpose is to align this linkage. One end of the linkage has a notch out. The notch out goes up here on the brake lever stud. And the other end hits the other stud. And the other clip snaps on right here to the end of the stud. Nice. Snapped right on. Always give it a rotation to make sure you got it on right. We can confirm the action. Everything looks good. The brake band will link on right to here. We'll turn it sideways, hook it, and rotate it back. Work it into the groove in the retainer down here. When you pull the brake handle, it pushes the pawl forward. That releases the brake. We want the pawl all the way back so it's easier to put the spring on. So we're going to engage the brake. We'll hook the long end of the spring to the pawl lever, and we'll use this spring tool screwdriver to set it on the stud here. Just like that. Sets it right in there real nice. Let's give it a check. We'll pull the brake lever. Our brake is disengaged. We'll push it forward and engage it. Engaged. Release. Engage. Release. Engage. It looks pretty good. Try to put the cover on now. We'll come in straight vertical. Try to get this top AV buffer in. Hit it with some Sil Glide and it'll push right in. Then we're going to rotate the handle down. Work all the wires through. The wires come through a grommet in this left hole. The pulse tube comes through the right hole. The fuel line comes up here in the center. And of course the intake comes through the main hole. The intake can be fingered through. I like to use a toothbrush as a poker because it won't poke through the rubber. You can use it as a soft pick, a plastic pick, for prying and pushing. Get the pulse line protruding and then pull it through with a pair of needle nose. Carefully, you can damage it. It'll lock in that little groove when you get it in right. When you're incorrect, your fuel line clips in here to the left, wires are the center, and pulse line is on the right. When you put the carb on, it'll slide over the studs and should hit both lines. I got both AV buffers installed in the handle. Put the handle face down and drop the saw down through it. And the buffers should snap into their spots. And now we'll put all our screws back in. This front lower AV buffer has to get pushed in before the handle goes on. Here's the old one. I decided to replace it. Well, you can get the exhaust bolts on with the cover on. The 2.9 and the 310 don't take an exhaust gasket. Only the 390 model utilizes the exhaust gasket at the bottom. The 2.9 and 310 just use the retainer. It fits the cylinder pretty well, and the muffler's shined up nice. We can put the spark arrestor screen in and then put the cover on, followed by the 3 nuts, and the muffler's done. The handle should snap on pretty tight here. Shouldn't be much of a gap. Then you got 2 buffer screws and 2 cover screws on this side. We can finish up the carb side. We'll put the carb nuts on. The breather grommet can go on the carb, and the cover grommet goes in the side here and aligns with the adjuster screws. To hook up the throttle, we got to take the handle cover off. We'll hook the throttle rod to the carb first, raise the trigger up, and we'll snap the throttle rod right into the trigger. Clicked right in. That looks good. We'll pull the spring down. We'll hook the safety lever onto the spring and snap it in. We'll put the handle cover back on. 1 screw in the bottom holds it on. And check the throttle. We're locked out. Now we work fine. We'll tuck the tank vent in behind the carb. The air filter goes next. There is a baffle that's supposed to go in here. Acts like a gasket. We got to align the breather and secure it down with the 2 captive nuts. I can see we got a pretty good connection between the air filter and carb. That looks good without the baffle. The pre-filter can go on above the air filter. There is an aftermarket cover available, but it doesn't fit. It looks decent for $4, but it doesn't latch on or line up at all. And the 361 cover has the same cowling as up here, but it won't fit either. So I had to buy a real one. It's $20, but it does fit. Even locks and latches on real nice. We're ready for a bar and chain and fire this thing up. I found a chain catch. We got a used chain skid and an aftermarket cover. This should do just fine. Well folks, there's your proof. If you don't maintain your equipment, you can catch your saw on fire, and it will burn up. Whenever I do the engine work, I always put a lot of oil in the cylinder, probably more than you need. And on first startup, I shove a rag up here by the muffler, and it'll discharge a lot of the extra oil right into the rag. If you don't put a rag here, it'll turn this whole area black. It'll blow all the oil out and turn this entire area black. So shove a rag in here on your first startup, and it'll pick up a lot of that oil. And it will smoke. It will indeed smoke. My advice is to let it smoke. Don't confuse burning assembly oil with a rich condition. So don't lean it out too soon. Run it for a good 5 minutes and just tough out the smoke. After a good 5 minutes, you'll burn out all the assembly oil, and then you can do your tuning. But don't be too quick to tune. A lot of times it's not rich, it's just the assembly oil burning. So don't be too quick to lean it out. You can use any oil you want to put this thing together. It doesn't have to be two-stroke. Two-stroke oil is the only oil intended to be ran through a fuel system and be combusted. Motor oil, 90 weight, assembly lube, that's not intended to be ran through a fuel system and be combusted. So that's why people tell you to only use two-stroke. But as long as it's a decent oil, you can use anything to put it together. And the important thing to remember is it needs to continuously be lubricated. You can use any oil to assemble it as long as the lubrication continues. Well, how many parts did it actually take? Here's the OEM parts list. We got a filter cover, we got a pre-filter inside, we got an AV buffer, and we got the oil pickup tube. Aftermarket parts include the plastic style case, the clutch cover, the pole starter, the carburetor, the air filter, the crankshaft is aftermarket, the seals and bearings are aftermarket, and the piston and rings are aftermarket. The clutch needle bearing, the clutch springs, the fuel line, oil line, and pulse tube are all aftermarket. Bunch of junk melted onto the handle, but the handle is still good. It's still very strong. It's not going to break. A flap disc or a trip to the belt sander would dress this handle right up, and you would have a decent OEM handle. And all that combined equals this much. And that's about what the saw is worth. This thing's worth about 200 bucks on the used market, and I wouldn't expect to get much more out of it. Some of the sellers on eBay think they're worth a lot more, but I say it's worth about 200 bucks. We're going to brand this thing with a few of the aftermarket stickers. Anytime I use aftermarket components, I always throw a few aftermarket stickers on here. It's always good to brand it with the brand you use. But it is indeed a fine saw. There is nothing wrong with this saw. The weight is nice, the power is nice, an 18-inch bar handles most jobs, and it will make a good backup saw. I'm sure you already know when a saw is this far gone, you don't rebuild it, especially not with OEM parts. The solution is to buy a new saw. Go down to your Stihl dealer and buy a new saw. You would only rebuild this if you were looking for something to do and you wanted a project. But you can indeed build yourself a good backup saw. But as far as making money off of rebuilding saws like this, there isn't much money to be made. All you do is get yourself another saw for your collection. This is about number 25 in the backup saw collection. The benefit of the aftermarket parts world is you can take a saw that's this far gone and put it back together. That's the number one advantage of the aftermarket parts. But if you're going to try and tackle a project like this with OEM parts, don't even consider it. Just go down and buy a new chainsaw.